Today we're going to talk about what are called Lewis structures, and they are used to help us understand concepts such as bonding and electron activity and things like that. So if we start with the basic idea of Lewis structures, I want to show you how we use the periodic table here, and you don't have to redraw this obviously, but this is a scale version of the periodic table. And what you'll find is when you get above each of these groups, you have group 1, group 2, and then we have these 3 through so on. And you have 13, 14, and so on. It's also possible, though, that you have Roman numeral versions. Okay, so you get obviously Roman numeral 1 and 2. We don't really worry about this region right in here for a variety of reasons, but then here we would have group 3, group 4, and so on. And if you have a periodic table, then you'll know what this looks like. But we should also go back and look at these two groups because they are separate. And then we can talk about how there are 6 groups over here. And 1, 2, 3, 4, 5, and then this actually, you could do something like that. Okay, so that's how it should be. So pink goes over here and so on. Now the reason we need to know that is because when there's a chemical reaction, and I'm just going to call this A, I'm going to talk about how the chemical reaction really occurs only when the outside of the substance is reacting. So we know that we have, for example, whatever the chemical is, the element rather. So let's say there's 3 electrons on the outside. There's always 2 on the very inside circle, my fault. Okay, so let's say we have this, and it comes on another atom that has 3 here, and let's say it had 2 here, then 1, 2, 3, 4, 5, and 6. And so what happens is it's the outer electrons that do the reacting. And so when A and B combine, these regions in here, the insides, are actually unreacted. So they're called core electrons. So I can maybe put those in yellow. These ones on the inside, they don't react. And so we're not going to worry about them. And it turns out that the outside number of electrons, these are called the valence electrons, which means they are outer electrons. Those are the ones involved in bonding, and they're also the ones that are involved in the chemical reaction. So they're involved in bonding. That's the most important thing that we're going to do. So we have to figure out what happens when A and B come together. How do we distribute these electrons? And so there's a couple of rules here, and we'll cover them, and then we'll do a whole bunch of examples. Let's go back to the basics. First of all, number 1 is you have to know number of valence electrons. You have to know that. Okay? So when you're looking at a periodic table, you're going to use that group number to determine how many electrons. So if we look at this chemistry reference sheet, also known as the periodic table, now we can talk a little bit more about how many electrons are around the outside of atoms. It turns out that every element here in group 1 has 1 outside electron. So I could, if I wanted to, I could draw a single dot because that represents 1 outside electron. Okay? And then we could look at group 2. And the rule is that when you have 2, right, that the 2 dots go together. Now we don't have to draw them on the side or the top, but we do have to draw them together. So everyone in that group gets 2 electrons. Okay? 2 dots. Now we could draw these here in the middle, but we don't, for reasons we're not going to get into. And then if we go over here, when you draw the first 2 dots together, like this, you can put them here, then the next one has to be separate. So we could put it here, for example, and everybody in this column is going to have the same setup. And then for carbon here, 2 would be together, so I could draw these 2, and then the next two are separate. And finally, I'll show you nitrogen. So the first two dots always go together, and then 1, 2, 3. And maybe not so finally. Let me show you what happens with oxygen. The first two dots go together, and then 1, 2, 3 separate. And then the next one starts to pair up with this other electron. Okay? So let me show you how that works, because you need to know how. I guess you don't really need to know how, but it's probably helpful. At the order, if you're doing a single element, right? That it goes 1, 2, 3, 4, 5, 6, 7, 8. Okay. So when you put electrons around here, it'd be 1 and 2, 3, 4, 5, 6, 7, 8. And for now, that's all we need to know. You should use a group number, right? This comes from the group number to determine, right? Let's make sure, though, if we're in group number 16, though, that only means you get 6 electrons. If you're in group number 18, that really means you only get 18 electrons on the outside, not 18. You get 8, rather, instead of 18. Okay, so that shouldn't be too hard. Number 2 is you total the number of electrons from all atoms. And I'll show you how to do that. Okay. Another rule is that single bonds use 2 electrons, double use 4, and triple use 6. There are no quadruple bonds because we can't make that happen. Okay. So a single line represents 2. And then we could talk about some other rules. There's something called the duet rule, which means 2 electrons, and that really only applies to hydrogen. It means that hydrogen is kind of small, and we can only fit 2 electrons around the outside. The most common rule is called the rule of octet, or the octet rule. And that means for most atoms, we're going to fit 8 electrons around the outside. And we'll talk about how that happens. There's something called the expanded octet. And then you could have as many as 10 or 12. And that's unique. That happens to be with things like phosphorus and sulfur sometimes, and our noble gases. So those are the basic ideas of some of the rules we're going to deal with. We're going to play with the rules as we go, though. And so that's going to help us to see how to do basic examples. All right, so let's get started with some ideas here. A classic example, I think, is that when we do something like CH2Cl2. Now, what am I looking for when I do this? First thing I have to draw is what's called a skeletal structure. And that means just the basic bonds. Number 2 is that in this case, carbon is generally the central atom. Not always, but mostly. We'll talk about the other rules about which ones are central. Okay? So let's follow our procedure here. And what we do is we say, well, carbon has 4 electrons because it's in group 14. Hydrogen has 2 times 1 electron because there's 2 hydrogens. And then chlorine has 2 times 7 electrons. And if we add that up, 14, 18, there's 20 total electrons that are going to go around this molecule. Some will be in bonds and some will be unshared. That means they're just going to be 2 extra dots. Okay? So what do we do now? If we take this color here and set it up so that we have this situation. We know that carbon is going to bond with the hydrogens and chlorines. It doesn't really matter where we put the H's, so let's just put them here. And then we have chlorines. Okay. Now, a close-up of this would show that that single bond, you don't have to draw this every time, but there's actually an electron going this way and an electron going that way. Let's just say that. That's kind of what's going on. Right? So there's 2 electrons in that single bond line there. So what I like to do is, I know I have to reach 20. I have to get up to 20 electrons. So what I do is I count 2, 4, 6, 8. And I have to get to 20. I also know that hydrogen can't fit more than 2 electrons. So hydrogen is unable to support any more than that. Okay? But let's go to this duet rule up here. That's what we're talking about with hydrogen. The octet rule, however, is for all these others. So how does that work? We have 8 electrons, and we have to count up to 20. So what you do is you count up to 20 by distributing the rest of the electrons away from the central atom. So we have 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. That is a completed Lewis structure for CH2Cl2. How does that work? Well, there are 2 electrons here, so that is satisfying the rules. This structure has 8 electrons, 2, 4, 6, 8. So does his friend here, and so does this carbon in the middle, right? Everybody has to have either 8 or 2. So 2, 4, 6, 8 for that CH2Cl2. Let's try another example here, this time with a very common example of water, H2O. And if I look on the periodic table, H is 1, but there's 2 of them, so I have 2 times 1 electron. And then oxygen is 6 electrons. So I have a total of 8 electrons that have to go around this structure here. I draw the basic skeleton, and now it would be this. Sometimes it's the fewest, often it's the fewest in number is your central atom. Okay? But remember, hydrogen only needs 2, so these hydrogens are already complete. But I counted up to 2, 4. I have to get rid of 4 more electrons to get up to 8. And so what do? Just put them here. And so how does this work? Hydrogen has its 2, so it has satisfied the duet rule. And then oxygen has its 8, and so it has satisfied the octet rule. Okay? So that's the basic idea. Let's do a couple more because it does take practice. Okay? If we take, let's find our purple here, so let's take CCl2 F2. Okay. Kind of exotic, but we could do it here. So what happens? Carbon has 4. Fluorine has 2 times 7. And then fluorine has 2 times 7. That's 14, 28. There's 32 electrons that have to go around this entire structure. Okay? You then draw the skeletal structure. And again, you don't have to draw it with the F's on top. You could draw them across and so on. Generally, though, you probably wouldn't put a Cl here and then the other Cl here. But that's personal preference. That's just pretty much how it goes. How many electrons do we have currently? 2, 4, 6, 8. And we need to get up to 32. The rule is distribute the electrons away from the central atom for reasons we'll talk about in the next video. So what do we have? 2, 4, 6, 8, and 10, 12, 14, 16, and then again 18, 20, 22, 4, 6, 28, 30, 32. It's not a big deal that you do it exactly the same order, but keep them away from the central atom. Now you might say, wait a minute, this central atom already had 8 electrons. That's true, but that's not always going to be the case. So the rule is go away from the central atom and it will work better for you. If you look, fluorine has 8 electrons, and so does his twin brother. And then here, chlorine has 8 electrons, and her twin sister. And then we have this. Okay, So that satisfies the rule that we have octet, 8, and we also have used up all 32 electrons. So let's do a quick review, because now we're going to talk about later on what happens when you have to do single and or double and triple bonds. Okay, so the general idea of Lewis structures is that the outside electrons are the ones that are bonding, and so when there's a chemical reaction, these outside electrons are going to get redistributed, probably. We get the number of electrons from the group number here. We generally don't worry about these because they have a little bit of a different chemistry. Okay? But if you see group 13, that really means that you have 3 outside electrons, not 13. 14 electrons, or 14 in this group, means you have 4 electrons in the outside group. Okay? And we talked about these rules enough that we don't need to see them again. Okay? But later on, we're going to talk about single and triple bonds. When you're starting out, probably the best strategy is to do the same way every time. And so you have carbon here in the center, and then after you count up all of the electrons involved in bonding, then you are going to distribute them in a skeletal structure, right? Remember that hydrogen is unique, that it has 2 electrons and then it's filled, okay? But most everybody else has 8, and we're going to change that a little bit when we go to the next video. Okay. Once you're done, your goal is to get up to the total number of electrons you counted. And so once you count all those single bonds, you then add up until you get to your goal. Okay. And finally, make sure you count to make sure that every atom except for hydrogen has 8 electrons on the outside. So the 2 rules you have is 8 on the outside for most everyone, and that you've used up all of the electrons that you started out with. So that is our introductory video. I guess we could go back and call this Lewis Structures 1. In the next video, we will talk about double and triple bonds, expanded octet, and resonance structures.